general purpose robotics AI solutions will solve self-driving, indoor navigation, household cleaning, all better than any specific solution ever has until that point. You can simulate it in all kinds of driving conditions that you're worried about. You can have the confidence, okay, look, it's not made mistakes for this amount of time, and in all these adversarial cases, I'm confident that, it's reliable.
I mean, especially if you're driving long distance on the freeway, a lot of people, I think, could put good use to that. So,
this is a pretty modern machine learning solution. It learns from human driving.
Instead of asking you questions, I'll just have to buy one of these, test it out, and see how it goes.
You can try out a self-driving car literally this week if you want.
I mean, as for my background, I'm not sure there's all that much to say. I mean, I've always been kind of tinkering with stuff and building stuff, and then decided to get an engineering degree. And then after that, I came to America, moved to California, and did a graduate degree in electrical engineering, and kind of always had like a vague interest in AI. I mean, always kind of seemed like it'd be more and more relevant as time goes on, but didn't really do much with it. I was working on like electrical engineering projects. I worked on some side projects and won some competitions in college that were kind of unrelated to AI. But then the first job I applied to after getting my graduate degree was to be an intern at Comma. That was back in 2017, and basically got that job. And I was working as a GPS engineer at Comma in the beginning. I did that for like probably a year or two, doing like classical SLAM algorithms and classical controls, that kind of stuff. Then graduated into machine learning and eventually became CTO here, basically running all of the machine learning stuff. And I mean, we do pretty sophisticated machine learning at Comma. Not sure how familiar you are with exactly what it is we do or how the system works. But yeah, I think we try to build like an end-to-end machine learning driving system, which means learning to drive by watching humans drive. So there's no hand coding, no rules, stuff like that. And so far it's been pretty successful. I mean, what we've shipped is truly end-to-end and has learned how to drive from human behavior. So that's kind of the short rundown, I guess.
Yeah, no, obviously we researched your project before you come on, but it's also good to like have you explain things like we don't know what it is just for the audience, but it's pretty incredible. I told Hunter I was like blown away by what you guys are doing. So from my understanding, the Comma is the company, and then the technology behind it is Openpilot. Is that correct?
Yeah, exactly. So I mean,
Okay.
Comma is a company, and we sell devices. Like our most recent product is a Comma 3X, which is a device you can install in your car. It runs Openpilot, and it will give you essentially Tesla Autopilot-like functionality on cars that would otherwise not have it, like Toyota Corollas or Honda Civics, stuff like that. And yeah, it gives you, it'll control gas, brake, steering, and can basically drive for you on the highway. I mean, it's level 2, you have to pay attention. And we are trying to expand that, similar to Tesla FSD. I would say our approach is quite different, though. As of recently, Tesla's kind of pivoted towards more end-to-end. Not really clear to me yet what they mean by that, but it seems like they're going more in the direction that we've been kind of aiming for a long time, and seems like they're making a lot of progress there. So.
Yeah, no, that's crazy. So just to be clear, like someone can use the code on Openpilot, for example, put it on their own computer and run this in their car right now if they wanted to?
Yeah, I mean, in theory, it's not quite that simple. Like, okay. You got a computer set up to support it, and then you need like an interface to actually connect to the car, and you need like a camera that looks similar to the cameras we use. But I mean, basically, yes. And I mean, it's licensed so that you can do that. But there's some like practical implementations on running it on arbitrary hardware.
Okay, so does Comma offer a product that the end user could buy to make it simpler for them?
Yeah, so that's the Comma 3X. So that's just out of the box. You just install Openpilot, everything works. That's what we sell.
So you're saying in the U.S. right now, or I don't know if is it available in the U.S. or is it available everywhere?
Yeah, I mean, it's actually quite interesting that you know what Openpilot is and you don't know. I mean, this has been a recurring theme, I think, is that you know what Openpilot is, but don't know that we sell a product that runs it. And I really wonder why that is, I guess.
I don't know. Well, it's because I guess from my perspective is like I hear things about self-driving cars with Tesla, other big car companies. But to hear that you can buy a product and then put it in your car to self-drive when Tesla doesn't even have that perfected yet. And I know that, I'm sure you guys it's always a work in progress. But I was like, how is this not a bigger story than I've heard about before? Because it came out of nowhere,
But I mean, to be clear, it's not a self-driving car, right? It's level 2 ADAS.
Okay.
similar to Tesla Autopilot. But just to give you some information, like, so out of our user base, I mean, I'm just looking at our own website now, and so yeah, 56% of miles driven are driven by Openpilot with users that have the system installed. So it drives a lot of the time. Humans have to pay attention and take over when it makes mistakes, but it is clearly very actively used and useful.
I mean, is it true that like self-driving cars, nobody's has that right now, right? Like, and that might not happen for a while.
Yeah, I mean, that's my perspective. It depends what you mean by a self-driving car. Like Cruise and Waymo are driving cars with no actual driver in the driver's seat that
Okay.
take passengers. But there's a long list of caveats. Whether you call that a self-driving car is kind of depends on what you define. I would say no, because they're supervised remotely. They operate under caveats that I think kind of deal breakers. But yeah, I think there's no legitimate self-driving car, and there's not expected to be anytime soon, is my perspective.
But if you got 56% of the time driving, that's pretty awesome. I mean,
sure, but it's like 56% is great, and that's a very useful product, and which is why our users like using it. But you know, even if you're at 99%, if you want a real self-driving car, you need 99.99999, right?
Sure.
Humans don't get into accidents that often, and you
Okay.
need to get extremely high reliability to replace that.
I guess my point is just for the fact that you can 56% is a pretty large number, and for not a lot of people know about you guys, and I think that's a huge thing. Like someone could go out right now, buy your product, and have their car be self-driven by you. I know I'm using the wrong terms probably, but
Yeah, I mean,
assisted 56% of the time. That's pretty significant and pretty awesome. I mean, I don't think I think the large majority of the public does not know that this product even exists.
Yeah, no, I agree. Wish more people would know about it.
So how long have you been with the company?
So I've been with the company a little over 6 years.
And do you know how long the company's been around?
Yeah, I think like it would be like maybe 2 years prior to me joining.
And then you mentioned that you came to the United States. Where did you come from? Where are you from originally?
So I'm from Belgium originally. So I went to university there and stuff, and then
cool.
moved here for like my graduate studies on a scholarship, and kind of went from there.
So there's obviously two sides to this. Like there's this AI component, behind the scenes component, and then there's some sort of hardware component. Could you just tell us about each of those components? What does this hardware look up like if somebody gets your product, the Comma 3, and what does it look like? How do they actually hook it up to their car to get this working? And then what is happening behind the scenes to get this working?
Sure. Yeah, I can give a quick overview. I'll add some context as well. Is like when Comma.ai started, that the big thing that we were standing behind is that this is predominantly a software issue. That the reason we don't have self-driving cars is not because we don't have good actuators or good hardware or good computers. It's because we don't have the software to be a self-driving car, right? So the focus at the beginning especially was to be driven by AI. And at that time, we were essentially using Android phones like OnePlus 3Ts and laterally Ecola Pros, which we were repurposing, flashing with new OSs, and running Openpilot on them, and selling that with some additional electronics. Now we sell something that is purpose-built and is completely built in-house and actually designed to like run in your car and stuff. But in essence, a lot of the parts are still there of it being essentially like similar to a mobile phone in that it has, central computer, it has connectivity, it runs, some version of Linux, it has cameras, it has microphones, it has speakers, and then that interfaces with the car in, something that we call the Panda, but it's essentially some kind of CAN interface that allows us to read messages from the car's CAN bus and send messages on the car's CAN bus. And the way it works on most cars that we support is there's a camera mounted in the windshield that will send messages to the car to steer left, right, and to brake, to use the car's own like AEB system, ACC system, and LCAS system. And so we can read those messages, reverse engineer them, and then when we run Openpilot, we block their messages and send our own, essentially having full electronic control of the car, while still maintaining all their APIs. So all the safety systems that they implemented for themselves are still completely active when we use it. And that's a really important distinction. There are ways you can, electronically control a car that you definitely wouldn't want to drive on the road. And we don't do that. This is the way, these APIs are intended to be used.
I mean, there's a huge safety concern, right? Like, so are there any kind of regulations that you guys have to work with in order to put your product out on the road?
So not so much regulations as like specs and guidelines, like there's the ISO specs. And yeah, I mean, they're extremely clear about what they recommend, and we follow all those recommendations. I think almost all of them are very sensible. And I can give you examples of what those are. It's like, so we have a safety model that we abide by, that's we like came up with, and it says a few things, which is, if you take over control of the vehicle, you should always have control and not be resisted, right? So control should always be given back to the user when the user wants it. That makes total sense. The second is, the car should never react so quickly that if the user notices it doing something wrong, it doesn't have time to take over. Like, for example, you could imagine if you turn the wheel so quickly, even if the human was paying attention, they couldn't safely react. So that's also, it shouldn't react so quickly. And then the last one is that a human must be paying attention at all times. And we also enforce that by monitoring the driver, their head position, their eyes open, closed, etc. And all of those things are in some way also worded in the ISO specs. They'll say things like, the car cannot jerk laterally faster than this much over this amount of time. And we also enforce all those limits.
Okay.
So yeah, there's a whole spec, there's a whole guidelines, and usually people respect them, and we do too.
But there's no like legal things that you have to go through to test the software through government regulations or anything like that. It's all just recommendations. Is that correct?
Yeah, exactly. They're recommendations. They're sensible, and generally people in the industry follow them. That's kind of how it works.
So, for example, when you like say if the car was about to get in an accident and the person's behind the wheel, but he doesn't have his hands on the wheel, it's from what you're saying is the program Openpilot's not going to jam on the brakes super fast because it's going to be too fast for your threshold. So the person would have to sort of see what's going on as well and then slam on the brakes himself.
There's some nuance there, which is there's some limits on how hard you can brake in what's called like ACC mode in the systems, which is, if it requires extremely hard braking, what is expected is that you enter AEB mode, which is automatic emergency braking, which most modern cars ship with, and is active even when you don't engage any of the assistance systems. So even when Openpilot is disengaged, for example, on the cars that we support, the system's AEB will still kick in. And so that in the spec also, if you use that, you're allowed to use very high braking. And there's some more different caveats there. Where you can never really be jerky under any conditions is with the steering.
And so, what is the use case most of the time for Comma, the Comma system, or Openpilot underneath it? Is it mostly is the best use case for driving on the freeway? It sounds like.
Yeah. So it's a convenience feature. If you drive long drives on the highway, I mean, you'll hear people say this is how I feel about it. It just makes long drives on the highway way more comfortable. So I can drive 10 hours now, no problem. And sometimes I travel, I get a rental car, and I have this attitude of like 6-7 hours driving, no problem. And I always immediately notice like, oh crap, this car doesn't have Openpilot. This isn't as great as I remember. So I think that's the use case. Just like a really nice convenience on long highway drives.
And what does it look like? So you get on the freeway with it installed, and how does it work? Like, does it shift lanes a lot? Does it go in the fast lane? Do you set like certain speed limits? Like, how does it feel when you're actually in the car with it working?
Very similar to like cruise control, in that you set like a cruise control speed, and that's the upper limit. And in the default way that we ship, it just slows down for lead cars and respects the speed limit you set. We also have an end-to-end mode where it like use the gas and brakes the way it thinks a human would, in which case it will slow down for turns, it will drive what it thinks is an appropriate speed, stop at red lights, stop at stop signs. We call that experimental mode. It's not really that polished, and only like 25% of our users use it because it's not that polished. But yeah, so those are kind of the two modes. And the way you use it, I mean, again, we override the buttons of the stock ACC of the car. So it's the same as engaging cruise control. It's just when you engage now, cruise control, it's like it will do, the whole thing. It will do the steering. It will brake for cars in front of you, that stuff.
So we'll switch lanes, everything, and then
so it doesn't change lanes unprompted. So the way it works is it'll stay in your lane, and then if you want to make a lane change, you put on the blinker and you touch the steering wheel, and then it will execute the lane change smoothly. But so you prompt the lane changes.
Got it. So it just sees that you're touching via camera the steering wheel.
No, there's like a sensor in the steering wheel on all cars, basically.
Really? Well, that's true. Like I know we just got a new Honda Odyssey minivan, and if you take your hands off, it'll say keep steering. So it sounds like that's what you're talking about.
Yeah, I mean, it's just a torque sensor. There's like every steering with electronic steering, you have a torque sensor that measures human torque on the steering wheel. to amplify it with the electronic steering, and you can just use that to detect like if the human's touching, basically.
So is that kind of why it can't be used on some cars? What's the limitation that determines it can be used on this car, but it can't be used on this type of car?
I mean, there's various limitations. Generally, it's just we need like a certain set of things, which a lot of cars have and some don't. So we need to be able to intercept the camera basically so that we can send steering, gas, and brake commands. Part of the thing that's necessary for our experience is we don't want people to have to touch the steering wheel to prove they're paying attention. We want, you looking outside forward and being awake to be enough. Some cars don't allow for that. They hard code you having to touch the steering wheel every 6 minutes, for example, in their ADAS system. Just random limitations like that. In some cars, the install is very inconvenient. You have to like plug stuff in under the dash or in the boot. That makes it kind of like impractical as a product. So there's all kinds of reasons, really, but a surprising amount of cars are supported.
So it's not necessarily an old car versus a new car. It's kind of these random little things.
Yeah, it's kind of random little things. Your car kind of has to be newer than like 2016, 2017, because that's when they started building all these APIs in the cars to start accepting these messages. So generally, that's kind of the threshold. Most likely, if your car has some kind of lane keep assist and like cruise control ACC, then it will be supported if it's newer, unless there's any weird stuff like I just mentioned.
Okay.
So you said there's like 56% of the time your users are using it. You mentioned it sometimes not being polished on certain tasks. So what is the limitation there? Where's the current work being done to kind of improve that 56% to maybe like 70 or 99?
Yeah, I can. So I just want to add to that it's 56% of miles. And given that most of the engagement is on the highway,
right. Yeah.
Different. That comes down to like 30% of time. But yeah, anyway, with that said, so we want to build an end-to-end system that basically looks at human driving and learns how to drive like that. We want to do this by writing a simulator and have the machine learning train in that simulator. That means that however good your final system will be is limited by the quality of your simulator. So one thing you could do is you could train in a classical simulator, like, for example, GTA 5. GTA 5 is a pretty good simulator. You can drive around and you can kind of figure out how to drive in that simulator. But it's not realistic. The road widths aren't real. It only shows American environments, whereas you want our system to work everywhere. So that's a no-go. I mean, you can build dedicated simulators, which is what some companies do, but it's kind of this endless project. Like, okay, now you've got to add the India texture pack and all that stuff. So we want to build a simulator that's based off real data, so that if we could just take in more new data, our system will become capable of driving in that kind of data. The way our simulator works now is essentially you take a video of driving and you can simulate like movements forward, back, left, and right by estimating the depth of the scene and reprojecting it. And this allows you to deviate from where the human drove. And then we can teach a model to recover from those deviations. Does that make sense?
It does. Is your philosophy, for lack of a better word, to go about emulating human driving compared to it sounds like your system is a lot different than other self-driving systems or self-assisted systems.
Yeah, I mean, what I would say the other ones that call them like rule-based, classical, in that they have some set of optimizations, which is like stay between lane lines, stay behind stop lines, don't hit pedestrians. We don't really believe that kind of stuff scales. We think the best way to do this is to mimic human behavior, and then maybe if you did that well, you can do some tweaks at the end. But I mean, we're nowhere close to that, and neither is anyone else. So yeah, that is a pretty big distinction.
And when you say like simulate human behavior, that's based off the simulation that you put in the machine that you're talking about.
Yeah, so there's more to elaborate there, which is that, so like I was saying, we simulate in the simulator where we reproject the scene, knowing something about the depth of the scene. But this is limited because the quality of that simulation is limited, first of all, by how good you can reproject and how much reprojection in general makes sense. And both those things are flawed. We are not very good at depth estimation, and you can't reproject the entire scene. Like, you can't reproject reflections. You can't reproject the illumination of headlights and other lights. So that's a big limitation there. And what you also can't reproject is counterfactuals. If you move towards a bus in the lane next to you, in the real world, that bus will react. But in our simulation, because we're just reprojecting, it won't. So that's a
Okay.
limitation of our simulator. And the biggest one is just in general, it doesn't look that good because reprojection isn't that great. And so when you ask, okay, why isn't it engaged more? That's the main reason. The simulation is limited in quality. And we want to move to a machine learning simulation, which is essentially just a machine learning model that just predicts video.
Awesome.
And that's what we're working on actively. Other people are working on this too. And once that works, we expect the performance of our system to just skyrocket.
It's a really exciting time. Like it sounds like, yeah, once machine learning it's better at machine learning, your product's going to be way better, like exponentially. So
Yeah, I don't know if I can send a video if you just want to see it of basically what we're working on.
that would be great.
It's difficult to get machine learning models to predict video, right? But that is the goal. And once you have that, it should predict the entire distribution of like human driving that it's trained on. And so that's extremely powerful idea, because then you don't need any engineers to hand code any rules, to hand code any types of road, any of that stuff. So it's super scalable.
So are you essentially writing your own like large language model for self-driving?
Yeah, exactly.
Okay.
So I just posted a Twitter link of a video we posted, which is just a video of basically that's completely imagined by this model that we trained. And that's kind of what we imagined this future of simulation to be. And you can see in the video, it's clearly not perfect. But it's pretty good. You can see the basics of what it's doing, and that's kind of the future that we're working towards.
And what's the back end tech look like? I know you're the CTO, so you have extensive background in this area.
Yeah, I mean, so what do you mean with the back end tech? Like how we train these?
Like
models?
what's your code? What code do you use? What's the? I mean, it's all open source, but like, what's the tech stack behind everything?
Yeah, I mean, it's so open source. We mostly use. I mean, the training stack's not open source, by the way, but we just use like Python. I mean, it's all pretty standard stuff. We mostly use Python. Some of the time critical and runtime stuff is written in C.
Is there any calls to the cloud or anything like that, or is it all locally on the computer, like in the car?
No, there's no calls to the cloud. I mean, so everything on the device runs on the device. Nothing happens in the cloud. And then even our training, we have a local data center that we built internally that runs all the training. We don't train in the cloud; it's very expensive. And I mean, those are some of the things that we actually are strong believers in and where we deviate from the norm is most companies train in the cloud. We think this is a really bad idea. First of all, because it's expensive. Cloud can be up to an order of magnitude more expensive if you have 100% utilization of training GPUs over a year. But it also just incentivizes the wrong things. It makes, let's say you want to do a random experiment. You think some engineer thinks, oh, if we change this to the models, they'll perform better. Now, if you're training in the cloud, that's a pretty significant cost to do that experiment. And it makes experiments harder to justify. Whereas if you buy an entire data center and it's sitting downstairs and it's idle, now all of a sudden you're incentivized to do experiments because the alternative is that your expensive GPUs are not doing anything. And so I think it incentivizes the right kind of behavior you want in machine learning research, which is that if somebody has some ideas, experiments are the answer, not like arguing about it and figuring out if it's worth the cost.
Yeah, I think you hit the nail on the head when you said you don't want those GPUs going unwasted. So it's like self-motivating right there to do something. That's cool.
Yeah, exactly.
Yeah.
So something we ask a lot of people who we talk to is a more general question about AI, apart from this project in particular. What is your general opinion of the direction of AI? And when I mean that, I mean, you can answer it as open-endedly as you like, but some people have said, we're going towards a time where AI is going to take these mundane tasks out of your life so you can focus on, other things. Other people say it's like has more of a relational component of like people are having more relationships with AI friends, AI companions, things like that. Where do you see the direction of AI more generally headed?
I mean, I'm not sure where I expect it to go, but I know that what I'm excited for is to have like household cleaning robots. Like if we live in a future where in like Fallout, you've got your own little nanny robot roaming around the house, keeps stuff clean, cleans up after you when you cook, cooks for you when you ask it to. That's what I want, and that doesn't seem impossible, especially with recent innovations. This seems like hopefully we'll all die with robots taking care of the house. And that just seems so incredibly exciting. Like I've got like one of those new Roborock vacuums that has like all the AI and LiDAR and whatever. I think it's cool. Like it's not actual AI by any modern standards, and it can be way better. But even that makes me happy. So if that's the future, I think it's possible. Someone's gonna build it. I don't know how big of a part of future AI innovations it will be, but that's the part I want to work towards, and that's what I'm excited about.
Heck yeah. I mean, if I've got 3 little kids of my own at home, and our house is a mess, so sounds
Right.
amazing to have someone clean up after everyone.
Yeah, no, exactly. And I
Yeah.
mean, you buy these cleaning robots now, and it just always feels like you're babysitting them, and less so over time. I mean, they used to be worse, but I expect, with the innovations that were happening now, in years, they will become incredibly reliable and hard to get them to mess up, which
Okay.
would just be incredible. I'd pay $20,000 for a household robot that cleans the house and doesn't have issues like at least once every few months. I mean, that sounds amazing.
Well, I mean, paying a cleaning lady once a week, it might equate to that much money anyways.
Yeah,
So,
and it comes with all these other issues too. Is okay, you got to talk to them, you got to make sure they're happy.
yeah.
The
I know
robot
it's a
doesn't have.
pain, right?
Yeah, exactly.
Yeah. But you guys have I saw you have a little robot too, right?
So we have what we call the Comma body, and so originally when the company started, our mission was to solve self-driving cars while shipping intermediaries. And when we say self-driving cars, we mean build some kind of AI solution that will, drive itself in a car. And that's much bigger than like encoding the traffic rules. We've always imagined some kind of end-to-end system. Like, how do you learn driving from scratch in a sensible way, right? And in our case, that means, start by looking at how humans drive and you start to imitate them. That's how we learn how to drive too. Because, you drive with other people, they supervise you, all that kind of stuff. And so now, we've made a lot of progress on that, and the rest of the world has too. And we've expanded that long-term scope in like solving robotics while shipping intermediaries. Self-driving is a subset of robotics, and in general, in both machine learning, anywhere, when you move to more general approaches, you tend to see better performance. It's like more work and long-term, but there's all these models previously, like language models, that would do stuff like they would do legal help, they would do medical help, and all these models and all these companies look ridiculous now in comparison to ChatGPT. And ChatGPT is just a general language predictor. And I expect the same will happen in robotics, which is that general purpose robotics AI solutions will solve self-driving, indoor navigation, household cleaning, all better than any specific solution ever has until that point. And so that's the line of thinking that we're along, and also why we're like randomly experimenting with like household robots, because it makes us think like, okay, what is the general purpose approach here that will solve all these problems better than anything specific ever has, which is what I expect will happen. I mean, it's what happened to language, and I think that's just generally how ML progress will go.
Okay, because the technology for driving cars can be ported over to robots pretty easily in a way. Like once you get it to
Yeah,
that point.
I mean, the basics is it's going to be video based. Humans navigate the world mostly through vision. So you're going to have some kind of machine learning model that takes in video, has some general understanding of physics and the scene around it, and will make some decisions based on that. And obviously, it'll be somewhat different when it comes to indoor navigation
Sure.
versus navigating on roads, but there is more similar than there is different. And
Okay.
generally speaking, when you generalize more in machine learning, you get better results. And so, yeah, we built this robot, and we built it as kind of an experimental thing to work with that, to think about robotics, to think about which solutions would work for both self-driving and robotics, and can they be better than what we were relying on so far.
Okay.
And so that's why we did it. And yeah, so this weekend we're doing a hackathon with them. We've got like 20 of those little wheeled robots. So they don't really do much by themselves. They basically run Openpilot, and we'll get people to kind of tinker with them. We've got like a little route through the office we want them to drive. That's kind of the challenge for this weekend.
Is
Like,
there a link to that as well that we can post? Or that's this weekend. I think it's going to be too late.
Yeah, that's this weekend. I mean, it's like an invite only event. But we'll try to post some like videos of how people did, and the prizes and the presentations at the end for what people did. I think we'll post all of that on our Twitter.
Awesome. Okay. And for someone that wants to buy your product, like what does the install look like? Is it sort of like installing like a dash cam or something like that? Can people do it themselves? Do you guys recommend someone install it for you? How
Yeah,
does
no,
that
it's
work?
exactly like a dash cam. It's pretty much
Okay.
the same. So you just like stick it to the windshield, and then there's like one cable you plug in by the camera, which just requires moving the trim. I mean, if you watch the instructional and you've got a normal car, it should take like 20 minutes. And then you route a cable down to the OBD2 port. It's definitely meant for people to do it themselves. It's not that hard.
All right. And can we ask you how much it costs as well?
Yeah, so let me just go to the website so I don't know. But yeah, it's $1,250 now, and then you need like a special cable for each car, and that's like $200. So all up, it's $1,450, and then should be good to go for the car.
I mean, especially if you're driving long distance on the freeway, a lot of people I think could put good use to that. So it's not too bad.
And we have a 30-day no questions asked return policy. If you want to try it, please. You can even try it on a rental car if you're just curious.
All right. And how does it work in terms of like firmware update? Well, it's not. Yeah, firmware updates and software updates, are those done over the wire, or like how do those get updated?
Yeah, so I mean, just connect it to Wi-Fi and it'll update. It doesn't modify the software in your car or anything like that.
I had a question about, you mentioned before, and then you mentioned again, how there's kind of there's a way you're doing things differently, and that's by trying to replicate human behavior. Rather than giving them a set of like giving the AI some set of rules, like stay between these two lines or something like that. And you said that scales better. Could you just kind of reiterate or go into a little bit, why do you think that scales better than maybe a rules type system? And are there any safety concerns with mimicking human type driving rather than some rule type driving?
Yeah, I'll answer both of those. So first of all, I can give you an example, right? Which is, you want to drive through an intersection. Your lane is clear, the light is green, there's a 45-mile-an-hour speed limit. Okay, no problem, right? You keep driving on your lane, no issues. What if there's a pedestrian, waiting to cross? Now, if that person's wearing a suit, right, and they look calm and they're just standing still, 3 feet away from the road, you're not going to bat an eye. That's normal. He's waiting to cross. But depending on the demeanor of that person, any normal human driver is going to react. If that person is like dancing around and looks like they're on drugs, which, I mean, I don't know if you live in California or not, but that is a thing that happens here.
Around me too, so I get it.
I mean, you're going to react differently. Or if that's a child, that's very young and looks like they're looking at some ball or something they dropped on the highway, you're going to react to that. And you might consider changing lanes or driving slower or just slightly erring away from the sidewalk. And that's stuff that really is relevant to driving and is important. And it's just a random example. There are many examples like this that you cannot really imagine which kind of rule set would encode that. So that's the answer to why we don't think that scales. Like, if you have a rule-based system, and you can see when people work on this, they just keep adding conditions and they keep adding things. And of course, they never got so far as to differentiate the kids from the adults. But if they kept working on it, at some point they would. And they deal with a lot of nuances now that are much less complicated than that, right? Which is, you have to follow lane lines. Well, yeah, usually you do, but sometimes there's constructions. Sometimes there's an exit and the lane lines diverge. Sometimes there are wrong lane lines. Like, there's all sorts of stuff.
So are most of the technologies that your competitors out there, or the self-driving or self-assisted cars that exist right now, are they all rules-based? Are you guys one of the only companies that are simulating human behavior?
Yeah, we're definitely the only one that's shipping to any consumers that's simulating human behavior. Tesla recently is claiming to do the same thing. They're doing it somewhat differently. I don't fully understand. They haven't released full technical details and they haven't shipped it to users yet. But it does look like they're pushing the same direction, which I think makes sense. I think they're at a good point to do that. And then there are a few other companies that are like us, and they say fully end-to-end all the way, no alternatives, but they don't have any products yet or really anything you can interact with except like demos.
Awesome. So you're one of the only players out there, which is great.
I want to answer that second question too, safety, which comes up a lot. One of the reasons that, I would say the older conservative people in this space don't like this approach is they're like, oh, it's a black box. How can you guarantee it works, right? And I mean, I think that's kind of a bad argument, because that's not how humans work either. How can I guarantee that you're going to drive well when you're on the road? Well, I can't, right? We have some tests that we do on people and some expectations. And by how they perform on those tests and how they perform in our evaluations, we make assumptions about how they will drive most of the time. And, you can make more assumptions about humans and how their brain works than you can probably do about AIs. But with some statistical tests, you can totally come up with a pretty confident statement about how the system will perform, right? You can simulate it. You can simulate it in all kinds of driving conditions that you're worried about. And you can do that on enough data so that you can have the confidence, okay, look, it's not made mistakes for this amount of time. And in all these adversarial cases, I'm confident that, it's reliable.
Because you could statistically analyze Comma. If you just like say Comma's a general driver and then compare him to any other driver out there on the road, you could say by statistically some stat, you could say, oh, they're better than 99.9% of all drivers on the road, something like that.
Yeah, exactly. I mean, we can't now, but
yes.
If you have a system that's a complete black box, but happens to be a perfect driver, I am very confident the issue won't be proving that it's good.
And back to what you talked about earlier, like driver-assisted cars, or I don't know the exact technical terms, but like, for example, my wife had a Honda CR-V, and in it you could, put on cruise control, right? Sorry. You put on cruise control and it would sort of keep its distance from the car in front of you. So if you put on cruise control at 80 miles per hour, I mean, everybody knows this, and the car in front of you slows down to 70, we're going to slow down to 72 because it's going to keep its distance. It doesn't change lanes, but it will stay in its own lane. What's the difference between what Comma offers, because you guys don't switch lanes, and what's already out there, like built into, say, a Honda CR-V right now?
Yeah, I mean, so they're basically the same feature set. I think there's just a massive difference in quality that, it's hard to put on paper, but I think the numbers should speak for themselves. Those people that have those CR-Vs, they may use those systems sometimes. They definitely don't use them, 50 to 60% of the miles that they drive. And I think that should prove that, there's some pretty significant difference there. But yeah, it's really just reliability. On the highway, our system is incredibly reliable and incredibly comfortable. It's not to the level of reliable that you don't have to pay attention, but it is to the level of reliable that you can, sit there pretty comfortably, have the system drive while you just look out for any anomalies. And that's a pretty big upgrade, right? I don't know if you've driven much with these other systems, but generally speaking, it won't take long before you end up in a situation where it slams on the brake because the lead car is going a little slower, but you would have hit the brakes later, for example, because it's way more comfortable, stuff like that. Like, it's just like this minor stuff where you just get annoyed very quickly when the system's not that good and not that polished.
Gotcha. And can you take your hands off the steering wheel with your system?
Yeah.
Which is a huge difference to what's built into cars. All right.
Yeah, I mean, it's hands-free for hours as long as you're paying attention and look like you're ready to take over.
All right. And if something does happen, is there an interface on this product, or is it just a black box sort of you put in your car? Like, is there a screen or anything like that?
There's a screen. Yeah. I mean, I don't know if you can open a new tab, but you can just open our website and you should just see a picture immediately of how it works.
Awesome. And so there is a screen. If there is any kind of danger on the road, does that flash for users, or?
Yeah, if there's like a reason to take over, so like we have forward collision warnings, or if there's an issue with the system or whatever, it will flash red and like beep at you. But yeah, the interface that you manually have with the cars is the same as it normally would be. Like, if you turn the steering wheel, it will let go of the torque and you'll have control. If you press the brake, the system will disengage, stuff like that.
And so if I take over the steering wheel and then I let go of the steering wheel, it just automatically goes back
there's like some smooth blending that it does.
Yeah.
Like, it will slowly release torque when your hands are on it. It will slowly re-engage it when you release. Yeah.
Cool. I mean, instead of asking you questions, I'll just have to buy one of these, test it out, and see how it goes.
Yeah, I think if you're excited about AI and stuff like that, and you want to have some fun on the weekend, support a car if you don't have one. Try it out. If you don't like it, you send it back.
All right. No, it sounds awesome. Definitely an exciting
and your
project.
website is Comma.ai, right?
Yes.
Make driving chill. Yeah, it seems like there's a lot of stuff on the website that takes you right through like all the different cars, the videos of the cars, kind of good breakdowns of everying. Easy to buy.
We're struggling with this issue of people knowing about Openpilot, not knowing that you can buy the device, which is funny because it's happened to you guys too. I mean, I don't know what we can do about it, because as you can see, we put effort to changes in the website, but I don't know.
Well, I think I found you guys on GitHub, like one of the most trending AI projects out there. So that's how I found you. I found you the reverse way,
I see. I think that is the more common way. I mean, we've got kind of more clout in that community, I guess, than in the consumer electronics community.
Yeah. Once your name gets out there, I'm sure that will change. What about, I'd imagine a lot of car companies are reaching out to you guys to sort of want to buy you out or have you partner with them. Is that true or no?
I mean, car companies reach out to us sometimes. Generally not for reasons that excite us or
Okay.
sound like good ideas.
Well, they gotta get their act together. I think that'd be a good partnership.
So you're more concerned about selling straight to the consumer. You're not planning on, at least as a company, planning on working with any companies in the future, or manufacturers or anything like that.
Not saying it should never happen, but we're not really planning on it right now. I mean, there's so many advantages to direct to consumer. One of the bigger ones is if we were to ship Openpilot on a car in a similar price range that we're mostly selling to now, we would have to make so many sacrifices in the quality of the experience, and we would have to make sure we'd have to figure out how to train smaller models that can run in the compute limitations of the modules that these cars would have. All these compromises that kind of take away from our mission of trying to iterate faster on some really good product or some really good AI product that people enjoy using. And those caveats are hard to get around. The other problem is their release cycles are just so tragically slow. Like if if we worked with them today, it would take like 4 years before that's on the road. And I mean, that means you'd perpetually have a 4-year-old system. Like that just kind of doesn't really work that well for us.
Okay.
And I mean, Tesla, for example, has a completely different approach to this. They have, OTA updates and new hardware and retrofits and all that stuff. So they also don't like this. So yeah, that's kind of why and also our software is MIT free and open source. We think car companies should use it and they should try it and they should put it themselves. It's free, it's legal, it makes complete sense. Companies like Lucid come out, they advertise this great ADAS, they ship, the ADAS sucks, they have the compute to run Openpilot, and somehow they're wasting their time developing an in-house system. Whereas even if they thought they could do it better than us, at least start with what we have. Don't start from scratch and not ship anything. I don't know, it confuses me.
Right. It's like more of an ego thing than anything, it sounds like.
Yeah, I think it's something like that. It's hard for people to not want to do it in-house or something like that. I don't know. That totally makes sense for them to try our software. It's free, it's licensed MIT. Try it. If you don't like it, then sure. But I think it makes sense as a car company, especially in a situation like Lucid, where you have the compute and no software, to start with something open source that works.
Heck yeah. Maybe one day.
Maybe.
What about so the software is free, obviously we went over that a lot already. What hardware, if you don't mind sharing, do you use for the system?
Yeah, so I mean, like I said, it's pretty similar to a mobile phone. It has like a Snapdragon 845. It has like a nice mobile phone display. It has like GPS and a connectivity chip. It has better GPS than a normal phone. It has like a high quality antenna, and then it has like 3 really good cameras that are like HDR for automotive use, very high quality, much better than a phone.
Is this is the hardware you guys built custom or had built custom, or is it something that was already on the market?
No, it's completely custom and built in house as well. We have like a circuit board assembly line and everything.
Okay, so it's not like you just went out and bought a cell phone and stuck it in here. This is something that's very proprietary on that aspect, at least, and you guys built in house, which is really cool.
Yes. So we used to repurpose a mobile phone with several modifications. That was like our product from years ago. And then, we, with what we learned from that, we started designing one from scratch.
And one more question. We're getting close to the end here, but are you guys VC backed? How did you get funding for this? Can you go into a little details about that?
Yeah, I mean, there's been some funding through the years. I forget what the total amount now is. I think it's like 18 million total. But I mean, we've had more revenue than we've had investment. And obviously we've built up a lot of valuable things like the circuit board manufacturing line, the data center. We want to eventually have made more profit than we got investment. Our goal is to be self-sufficient and profitable. We're not really looking at raising more investment. We kind of want to be bootstrapped.
Well, you're definitely different than most of the startups out there. I mean, you've been around for a long time, but
that's the idea.
Yeah, that's great.
Was there anything else you wanted to talk to us or share with us or the audience or anything like that about the project maybe we didn't talk about?
Just reiterate, I mean, the reason that I'm really excited about is that, this is a pretty modern machine learning solution. It learns from human driving. There's no hand-coded rules. And yet we made a product that, it's not super polished yet, and we're working on that, but it'll stop at red lights. It will stop at stop signs without us ever coding that it has to stop at red lights, ever coding what a stop light line is. And you can buy that today with a free refund if you don't like it. So, if you're into that, kind of seeing what the state-of-the-art ML products are like, I think it's pretty exciting.
Absolutely. You can try out a self-driving car literally this week if you want.
It's a new consumer product. I think it's exciting. Try it out. If you don't like it, send it back.
We study projects every day because we have to write tools and stuff for the newsletter, our newsletter, and your project really stands out. It's really cool, and not a lot of people know about it. And I think once they do, it's you guys will be very successful. It's really cool what you're doing.
Cool, thank you.
Yeah, there's a few times when we were researching different projects, and either Ryan and I will get really excited about a project, and Ryan's the one that found this project, and he was really excited about it. I mean, Ryan doesn't get that excited about projects that often, but this one he was really pumped up about. So
yeah, it's really fascinating what you guys are doing. So
I mean, we're excited about it too. I mean, most of us are here, a lot of times in the office, we're always kind of having fun and keep working on stuff. I mean, it's exciting to see this stuff come together, right? It's like building a consumer product in-house. We're doing these cool ML stuff. We've got a data center in the basement, It's also cool to see the whole trajectory, right? It's like we started in a house and then, you get a small office, you get a bigger office. It's cool to see the whole evolution.
Yeah, you're growing slowly, like not compared to most of the VC-backed companies out there. So that's more power to you guys. I guess now's the time to promote anything that you want to promote. The website is Comma.ai, correct? I don't want to make sure I'm not screwing that up. Any other kind of links or anything you want right now? Go ahead, feel free to promote what you like.
No, I mean, yeah, if you're interested in the project, I'd say just check out the website. If you're interested in the product, you can check that out. Otherwise, we've got our GitHub. We've got a lot of community contributors that either contribute a lot to our project, which is great. A lot of people learn a lot from it, which is also great. It's always growing. So if you're interested in this sort of stuff, just check out our project, check out the website, I would say.
All right. So yeah, check out the website, Comma.ai. Try it out. Very cool project. And check out Ryan and I's newsletter, AI newsletter, fry-ai.com. We do weekday AI news, Monday through Friday, cool tools, community, and the latest stories in a fun and easy to read, easy to understand way. And then we also provide some links and different things for you to look at. And then on Sundays, we do our deep dive articles into very cool AI developments, cutting edge stuff, cutting edge developers.